Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going over a concept my student has requested me to cover, which is the concept on permutation and combinations, or versus combinations as I'm going to be calling this. And the reason why is that a lot of times students do get confused around when do we use permutations, when do we use combinations when they see it come up. And they get confused about the equations that do exist between the two. So I'm going to create sort of like a comparison chart right here and explain the significant difference around these two concepts. And then I'm going to go into a quick problem about these in their original format, but also go into explanation around how to do them in a word problem and how to identify one or the other. So for example, permutation, when we talk about permutations, okay, we do want to describe this as a format that looks like this, NPR. And no, it is not the sort of TV show or whatever not that exists, but actually it is an equation that we use in statistics that exists. And how it works is that the equation for NPR exists as n factorial over n minus r factorial. And so these exclamation marks are called factorials, and what these exclamation marks do is that it's technically a symbol for a certain functionality. And so just to give a quick example below, or give example on a separate sheet of paper so that we don't mess up the chart, let's say I give you a factorial of 5 factorial. What 5 factorial literally means is it's going to be 5 times 4 times 3 times 2 times 1. It does not include 0, because if we include 0, it will always be 0 then. But because of this, it will end up being 120. And so that's the purpose of factorial. So if I gave you 100 factorial, for example, it'll be 100 times 99 times 98 times 97, ... We keep going multiplying until 1, and we get whatever value that will be. And so that's what the purpose of factorials is. But that's not the focus for today. Today is just understanding permutation versus combinations, but it does help to know what factorials are. And usually when permutation comes into play, okay, permutation usually means that order does matter. Okay, so some examples I could just think off the top of my head is that, for example, if I have 5 people and I'm trying to put them into lines and see how many possibilities exist for people putting into a line, usually these people will be attributed with names. So let's say it's Jane, Bob, John, Luke, and Christopher, right? So these 5 names, if I sort Christopher up front, or I sort Christopher on the back, or I sort certain people in a certain order, you can distinguish each individual that's in the line. That means that the order does matter and changes the possibilities that exist. This is a little bit different for combinations in this combination. Okay, for combination, usually it's indicated by this function at NCR, which is n factorial over r factorial n minus r factorial. Okay, so usually, I need to side note this for both of them, n usually is the total number, and r is the selected number. So that means that if I want to, amongst 10 people, I want to select 5 and put them into order, that's what it sort of means. And combination is when order does not matter. So what I mean by it does not matter is that, let's say amongst 10 people I choose 5 and I don't give them a name. It's just 5 people, and what are the total possibilities of these random 5 people I sort? Well, I can't distinguish one person from the other, and it doesn't really set into play who gets those certain spots. It's just saying generally what's the possibilities that exist. That's when order does not matter. And so just to demonstrate these type of questions and how to solve them, first, before I go into real life scenarios, I do want to do some problems on these. So for example, let's say I give you the question 7p4. How do I go about doing that? Well, according to the equation for NPR, it's going to be 7 factorial over 7 minus 4 factorial, which means 7 factorial over 3 factorial. If I want to go even more detailedly in how to go about doing this, it'll be technically 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. If you notice, if you want to make your life easier without calculator, you can actually do is take out these 3 times 2 times 1 and just use 7 times 6 times 5 times 4, which is technically 42 times 20 And just to calculate it, it will be 800, I believe, over 1, of course, which is going to be, I believe, 840 from mental math purposes. But that completes sort of how I could do that. But the difference is that if I do 7C4, for example, it's 7 factorial over 4 factorial, 7 minus 4 factorial, which is the same thing as 7 factorial over 4 factorial, 3 factorial, which if I want to continue calculating this will be 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1 times, duly note, 3 times 2 times 1. I just wanted to put parentheses to distinguish these. To simplify, I could take out 4 times 3 times 2 times 1 because that's the faster way to do this. So it will be technically 7 times 6 times 5 over 3 times 2 times 1, which is the same thing as 7 times 6 times 5 over 6, because 3 times 2 times 1 is 6. Cancel out the 6's, which will equal to 35. And that's how computationally, without it being involved in real life scenarios, I could go ahead and do permutation versus the combination. But let's say that I don't really want to do this by hand. I want to do this via calculator. So using TI-84, because usually for statistics I recommend TI-84s, this is how I could do NCR versus NPR. So let's say, for example, I want to take this exact same question, 7P4, and I want to punch that in the calculator. First thing first, I need to push 7. I am going to push math. So my button math is a little bit scratched, but right here, 7P, and I'm going to go to probability. There's a function that says NPR, which is the second choice. So 7P4, and it look right here, 840 matches with my answer right here. And so that's how I do permutations. But let's say it's not permutation. Let's say it's combination. Same thing. At 7, math. I'm going to go to probabilities, go to number 3, C, and then I'm going to punch in 4. Yes, so it's going to be 35, and it's shown right here. My answer 35 matches with this, and that's how you can go ahead and do it on the calculator. But that being stated, that's not really the questions that are provided on the AP Statistics examination. It's not usually that simple. Actually, it's a little bit harder, and it's usually in a real life scenario. And so I'm going to go ahead and do so. I'm going to go ahead and do this in a real life scenario based question. So I'm going to take away this paper and put it onto another paper. So in the real life scenarios, let's say that the question states that there's a ski club. Okay, there's a ski club that exists, and they're trying to choose 3 officers. They want captain, a co-captain, and they want a secretary. And in this ski company that exists, there are 10 members that exist, and they're asking you how many ways can these office positions be filled. So amongst the 3 positions, how could it be filled? Because these positions have titles, as I mentioned before, and they have names, automatically I have to identify this as permutation. Okay, so if I'm doing the NP, whatever format that exists, these are my 3 choices. 3 choices. So this is going to be my R for the NPR. For NPR, this is going to be my R, 3. 3 is going to be my R. 10 members, which is my total, is going to be my N then. So it's technically 10P3. And so just as much as I told you before, it's going to be 10 factorial over 10 minus 3 factorial, or aka n factorial over n minus r factorial. I could just do this on the calculator because I don't want to really go through the calculation aspect. So I'm going to first type down 10 math. Whoops. Go to probability, math 3, and it gives me 720. So there's 720 possible ways for us. There's 720 possible ways for us to go ahead and fill up these positions for these 3 specific positions that are titled, and thus why I know this is going to be a permutation question. But let's say we're doing a different question for this round. So let's say that, for example, let's say that there is a person, same sort of scenario. Let's just say that rather than the captain, co-captain, whatever not, there are actually just 3 positions. I don't know the positions' names. Maybe they're generic and whatever not. They're officer positions. Let's say all of them are going to be directors. And then because they're all directors, there's just 3 generic director positions that exist. Okay, and I'm going to draw a line so you don't get confused with the prior question. So there's 3 positions that exist, and let's say we're trying to choose 10 members. The difference is that for this is my N, this is my R, R. Oops, let's scribble that, R. And this is going to be my N. There is a significant difference because I don't know, there's no distinguishing between these 3 positions. I just know there's 3 generic director positions. So in order to do this combinations-based question, the way I'm going to do it is that I'm going to put down 10C 3, because this is a combinations-based question, because I'm able to recognize that there's no distinguishment between the positions or whatever not. And so because this is 10C3, I identify my R as 3 positions, 10 being the members or n, and 10C3, which is going to be my 10 factorial over 3 factorial, 10 minus 3 factorial. And so on the calculator, the way I'm going to do this is first put 10, math, go to probability C3. And that's why my final answer for this question is going to be 120. And that's how I'm going to be able to distinguish between the scenario between permutations and combinations. Thank you so much for watching this video. We're going to continue to make more FASTREV videos like this. So please do like our Facebook page to get updates quickly or to subscribe to our YouTube channel. And I hope you have a wonderful day.